Welcome everyone. Let's have a look at derivative of division and multiplication. If we have two functions and we are multiplying or dividing them and we want to differentiate these functions, we define the derivative in a really unique form. So if we have fx multiplied with gx and we want to differentiate this, we will differentiate fx and multiply it with gx. And then we will differentiate gx and multiply it with fx, and then we will add these two terms to each other. For the division of two functions that we want to differentiate, first we will differentiate fx multiplied with gx, and from this we'll subtract, we will multiply fx with derivative of gx, and this will be over square of gx. Saying this is really nice, of course, but we need to see that these are correct, right? So try to show both of these limits are correct, then solve one problem for each. In the next video, I am thinking of solving some problems related to differentiatings that we learned until now. Alright, f times g differentiated, right? What was our limit definition? Limit h approach to 0, fx plus h minus fx, and this is over h. We will use this to see what this is equal to. So our function is f times g, right? This is equal to f derivative x. So instead of f derivative x, we have f times g derivative x. We will write f times g x plus h minus f times g x. This will be over h again. We will write this as limit h approach to 0, f x plus h times g x plus h minus fx times gx over h. Now, the thing I'm going to do from here is not that easy to see, but after doing it, you will understand why it works, why it is the right process, right? I am gonna do a little trick here. I will use a little trick here. Gx plus h. If I say minus fx times gx plus h plus fx times gx plus h minus fx times gx. What did I do? I added two terms, fx times gx plus h, with the reverse sign of it. So these will cancel each other, so we will get 0 from here. So basically, I did not change anything, but I added two terms that cancels each other out. This is over h. Why this is important for us? Why did we do it? Now let's see. Limit h approach to 0. First, let's start with taking the terms under the gx plus h parentheses. I get one from here, right? Which is fx plus h. I got one from here. Another gx plus h is here, so minus fx. I have another plus fx here, but I'm not touching that. I am using these two. Now, plus, for the remaining terms, I want to take them under the fx parentheses. So I get gx plus h minus gx. You're probably already sensing it. We are getting the f derivative x and g derivative x, right, from these. All of this is over h. Let's write this in a form that we can see the derivatives. Gx plus h times fx plus h minus fx over h plus fx times gx plus h minus gx over h. If I plug the h's in for, we have one here, so that will be enough for us. Gx from here. From here, we know that this limit is the definition of our derivative, right? So this gives us f derivative x. Plus, we have fx here. Why I did not write gx plus h? Of course, I plugged the h in here. Plus, from here we get the derivative of gx. Now, for the proof for f over gx, right? The derivative of this is equal to something. Let's see what it's equal to. I'm gonna write my limit definition as usual. Fx plus h. Thanks that we tried to write something, right? Fx plus h minus fx, and this is over h. Instead of fx, but this is the definition for f derivative x, right? But instead of f derivative x, we have f over g derivative x. So let's start. H approach to 0. F over gx plus h minus f over gx. This is over h. Step by step, slowly, so we can see everything clearly, right? Fx plus h over gx plus h minus fx over gx, and this is over h. I want to write these in the common denominator, so we will expand this with gx, and we will expand this with gx plus h. We will get limit h approach to 0, gx times fx plus h minus gx plus h times fx. This is over gx plus gx times gx plus h, and that's over h, so we can write that as gx plus h times gx times h. Again, I want to use the same trick, but this time I am not gonna add the same function because when I look at it, I have a fx plus h here, gx plus h here. I need a minus fx and minus gx for these to be derivative of fx and gx, so gx times fx plus h minus gx plus h times fx minus fx gx plus fx gx. I did not change anything, but I will use these two terms to get the definition of the derivative. This is over gx times gx plus h times h. Let's take this part outside of the derivative because if I plug this in, I know if I multiply these two, I will get g squared x, right? Let's continue from here. 1 over gx times gx plus h from here. Now, inside, what should we do for inside? Let's see. We have minus fx plus times gx and plus fx times gx. Let's start with fx. Okay, then let's start with gx first. Under gx parentheses. It doesn't matter, but I think it's easier to see this way. I get the fx plus h from here. And I get the negative fx from here. And clearly this is over h, right? Now, minus fx. Since this is minus, this will be gx plus h, right? because there's a negative sign in front of it. For this to be negative gx plus h, I need to write it with the reverse sign of it, and for the plus, I need negative gx. So we don't change the signs. And this is over h. We really don't have enough space here. From here, what did we get? When I plug this in, as we said, we get g squared 1 over g squared x multiplied with, there's f derivative here, so gx times f derivative x minus fx times g derivative x, which is equal to f derivative x times gx minus g derivative x times fx over g squared x, right? Now let's see two examples for each. After this video, as I said, I'm thinking of making a problem-solving video, so we practice the things we learned. Fx is given to us. The question is of course derivative of fx. You can argue I can multiply these first and then differentiate each term, but since we learned the differentiation of the multiplication, let's use it. First, first differentiating the first term, right? 3x squared plus 2 multiplied with 1 plus x squared plus the second term's differentiate. Let's differentiate the second term. 2x constant is 0 multiplied with x cubed plus 2x. 3, I mean, you can leave it here if you want for this video, but let's go a little bit further. 3x squared plus 3x to the fourth plus 2 plus 2x squared. If we did not miss anything, right, it should be correct. Plus 2x to the fourth plus 4x squared. And that's it. Let's see, 3x squared from here. 3x squared, 2x squared, 5x squared. 4 more, 9x squared. We use these ones. Now, x to the fourth, there's 3 and 2, so 5 times x to the fourth plus 2 is our f derivative x. 9x squared plus 5 times x to the fourth plus 2. Division, the derivative of division, right? Gx, what is this? Derivative of gx. Differentiating the first term, 2x, multiplied with the denominator, 3x plus 1, minus, let's differentiate the denominator, 3, multiplied with x squared plus 1, and this is over 3x plus 1 squared. 2x times 3x, 6x squared plus 2x minus 3x squared from here, and minus 3. And this is over, should we expand this? Let's do it. 9x squared plus 6x plus 1, right? 9x squared minus 3x squared, 3x squared plus 2x minus 3. This is over 9x squared plus 6x plus 1, which is the derivative of gx.